Okay, so I want to take a look at some financial math problems, mainly just these investment type problems that you guys have seen last year, but we'll talk about them just to review them. So in this one, they all start out with you've got $1,000. You invested in a savings account with 2.1% annual interest, and then you have to find the investment at the end of 5 years. Depending on the way interest is compounded, you get slightly different amounts. So if it's annually, and for our class, if you don't mention compounding at all and you say annual interest, assume that it's compounded annually. So that just means at the end of the year, that's when you get a lump interest added to your account. So we know that the amount of money, the principal that you have, is whatever the initial investment is, 1 plus your rate to the time that it's invested. So this should look familiar. This is the same thing we've been using for population growth. So the amount that we invested was $1,000. Oh, by the way, T here is number of times we've compounded. And R is the rate for our compounding period. So I'm going to do these problems two different ways. First, I'm just going to use this formula over and over and over again. So it's 1,000, 1 plus, and 2.1% is 0.021. So that should make sense. This is the 100% of the 1,000 that we have, and then we're adding 2.1% every year for 5 years. Oh, actually, let me not write equals there. Let's do this. I'll move this over. Let's put that up here somewhere. Okay. And this is really, the reason I did that was this was the general formula. This is P of 5 for part A. Okay. And if you plug that into a calculator, you end up with $1,109.50 plus some small decimals that come after that. Okay, if we did it quarterly, that means 4 times a year, 4 times per year. And the way that we define interest or the way that we define compounding for interest is technically not mathematically correct, but I think the reason it's done this way is this is how most people would probably think about percentages, even though it's not technically right. So what you do is you say, this is how it actually works. This is how we would actually do the problem, even though, again, the phrasing isn't correct, but you don't have to worry about that. So it's 2.1% annual interest compounded quarterly. So the way that banks calculate what the quarterly interest is, the quarterly interest rate is they say 2.1% divided by 4 will be the interest that you get each quarter. So 2.1% divided by 4, let me figure that out. That's the same as 0.00525%. Or no, not percent. That's decimal form now. Each quarter. That's what you tack on. So another way of writing this out would be after 5 years, we're going to have 1,000 times 1 plus 0.00525 to the t, except that I'm not compounding every year, I'm compounding every quarter for 5 years. So I'm going to end up compounding 20 times. So if I do that, that'll get me what it is at the end of 5 years. So if I type that in, 1,000 times 1.00525 all to the 20th, then that ends up being $1,110.41. It's 0.40558, but that's about 41 cents. Okay, another way of writing this, if you wanted to keep it in terms of years, so this is in terms of compounding periods. If we wanted to write it in terms of years, then we could say P of 5 years is going to be 1,000 times 1 plus, and I'm going to write it this way, 0.021 over 4. And then I compounded it 4 times a year for 5 years. So I'm just going to write this on the side here. And there's a reason for that. I'll come back to it at the end. Okay, in part C, it's semi-annually, twice a year. So that's going to be 2.1% or 0.021 divided by, whoops, not 4, 2 to get my semi-annual compounding rate. So that's 0.021 over 2. So that's going to be 0.0105. So it's 1.05%. Twice a year is what my rate is. So, and since I'm doing it for 5 years, twice a year, I'm going to compound 10 times. So I've got 1,000, 1 plus my rate for that compounding period. And then I'm going to compound 10 times. So if I type that in, let's see, 1,000 times 1.0105 all to the 10th. That is $1,110.10. And if I wanted to do the same thing that I did over here where I keep it in terms of years, then I could write this as P of 5 years equals 1,000, 1 plus 0.021 divided by 2, and then I compound it twice a year for 5 years. So again, that's another way of writing this. Okay, continuously uses a different formula. Continuously means you're constantly compounding. And the formula for continuous compound interest, is the amount that you have left at the end, is this. That PERT formula might look familiar to you. At the very end of this video, I'll talk about where that e to the RT comes from, although I'm not going to prove it because we haven't taken calculus yet. It's another thing that calculus comes in handy for. So in this one, we're constantly, well, let me just do it, and then I'll talk about it. So this one is in, T here is in terms of years. So it's P of 5 years equals 1,000 e to the rate, and the rate is the annual rate here. So at least stuff is kept simple. 0.021 times 5. So if you plug all that in, you end up with $1,110.71. And you can see the continuously compounded interest gets you the most money. And then the more frequently you compound, the more money you get. This was the second most frequent, this one was the third most frequent, and this was just once a year. So one thing that we can do, and what a lot of people like to do, is talk about it in terms of years only, where T is in years. So if you wanted to do it this way, you can use this formula. Notice they always started with the initial investment, so P naught, or P0. And then it was always 1 plus your rate, 1 plus whatever the annual rate is, divided by however many times you compounded per year. Right, 4 here, 2 here. And then it was raised to the number of times you compound times the number of years. So number of times compounded times number of years. So over here on the side, I'll write a little key. P naught is the initial investment. R is the annual interest rate. K is the number of times compounded per year. And T is the number of years that you're compounding for. So you can use this formula for all of these types of financial mathematics problems. One thing that I'll talk about, and it's okay if you don't want to watch this part, this is not required. Where does that E come from? Well, continuously compounded means K, I'm compounding an infinite number of times per year. So K goes to infinity there, and K goes to infinity right here. And so what you can do is you can kind of look at this formula this way, right? Because 1 plus R over K to the KT is the same as the parentheses to the K and then the whole thing to the T. So if I were to look at the limit as k goes to infinity of 1 plus r over k to the k, just this part that's in the red brackets here, it turns out, using some calculus techniques, when you get into studying this stuff more, it starts to make a little more sense. This ends up turning into e to the r. It's one of the reasons that e is a super useful value in math. And e to the r, so if I'm constantly compounding. Why doesn't it turn into infinity? Because you're raising it to the infinity power. Well, think about this term, r over k. If k gets really, really big, this thing gets really, really close to 0. It's still positive, but it's very close to 0. So it's 1 plus a tiny, tiny bit raised to a huge power. So that's going to be, it's not going to explode necessarily, and it turns out that it zones in right on e to the r. So, so then our formula for continuous compound interest, instead of, it still has p naught here, but instead of this red brackets, it becomes e to the r and then to the t. So, okay, I hope that helps a little bit. And I think you've got a couple questions about it in the homework at some point between now and the test.